Hello and welcome to helpyourmath.com. In this video, we're going to look at money and interest applications very briefly as part of solving linear equations. I do another video in solving systems of equations where I do many more examples of money and interest applications. So here's just two examples, one of each type. If you need to see those, check those out as well. Also, you're really going to want to have a calculator handy, so if you need to, pause the video, go get a calculator. Let's get started. Melissa has some money invested in two accounts. One account pays 6.5% simple interest per year, and the other pays 8% simple interest per year. If she earned $1,085 in interest in the first year, and there's $4,500 more in the account that pays 8% interest, how much did she invest in each account? I know, deep breath. There's a lot to work with here. There's a lot going on, and it looks really scary. I get that. Totally understandable. I'm going to break it down as best I can for you. First, let's start with just the first sentence. We know that there are two mystery accounts. So let's talk about those accounts. We have some money invested, so we're going to say amount invested in account 1 is going to be, we don't know, so we're going to call it X. And then the amount invested in account 2, we also don't know, and we know that it's not the same value, so we're going to call it Y. Okay, we know that one account pays 6.5% simple interest per year. So we'll call this one the one that earns 6.5% interest per year, and that means this one will be the one that earns 8% interest per year. Now here's what we're told. She earns this much in interest. So we know that the interest of account 1 plus the interest of account 2 is equal to $1,085. One more piece of information that we're told. There is $4,500 more in the account that pays 8% interest. So there's more money in this account than in the other account. So how can we represent this? We can represent the Y value, the 8%, by saying that Y is the same as $4,500 more than the amount invested in the other account, X. So we're going to represent the amount invested in Y in account 2 not only as Y, but we can also call it 4,500 plus X. Okay, so what we need, this is the amount of money that's invested, but we need something to represent the interest from each account. So if she invests X amount of dollars into account 1 and she earns 6.5% interest, then the interest that she earns from this account, we could represent by taking 6.5% of X. Now, when we deal with percents, we have to convert them to decimals or fractions. To do that, somehow or another, you need to divide by 100. If you convert to a decimal, that means moving the decimal point 2 places to the left, which would give us 0.065 times X. If you divide by 100, you would just put it over 100 and you'd have a really awkward fraction with a decimal in it. Okay, what about this account here? So the interest earned in account 2, we can represent, she's going to get 8%, 0.08, times however much that is, which we called Y. And we'll come back to the other representation for account 2 in a minute. So we know interest from account 1 is going to be 0.065 times X, plus the interest from account 2 will be 0.08 times Y, and these two together will add up to $1,085. Now, this is a problem because we have one equation, but we have two different variables. However, we know something that Y is equal to. We know that Y is the same as 4,500 plus X. So what we're going to do is we're going to substitute in. Where I see this Y, I'm going to replace it with what I know it's equal to. And so that's going to give us, I'm going to scoot over here because I know I'm going to run out of room, 0.065 times X plus 0.08. And instead of Y, I'm writing 4,500 plus X. And all of this is equal to $1,085. Now, there's one more issue that I have. Generally, I don't work as well with decimals as I do with integers. So I want to clear the decimals out. And do you remember how to do that? We find the one with the least place, which would be this 5 that's in the thousandths place, and we multiply each term by that value. So we're going to multiply by 1,000. There are 3 terms here. This one is just one monster term. So I'm going to multiply by 1,000 3 times. When I multiply it to the first term, I'm going to multiply it to the 0.065. That's going to move the decimal over 3 times, and that gives me 65 times X. When I distribute the 1,000 to the second term, I'm going to multiply it specifically to the 0.08. It's going to move the decimal point 3 times, which gives me a gap. And so I put a 0 in that gap, and it's going to be 80 times 4,500 plus x. When I distribute to the 1,085, I'm going to add 3 zeros to the end of it. That's going to be 1,085,000. Now I want to distribute the 80. When I distribute the 80 here, I'm going to have, well, this is going to be 65x plus 80 times 4,500 is 360,000 plus 80x, and that equals 1,085,000. Okay, now I want to combine my like terms, and at the same time, I'm going to subtract 3,600 from both sides. And when I do that, I'm going to get 65 plus 80 is 145 times x. Oh, I put a 5 there. Let's try it again. Is 145 times x is equal to, when I do this subtraction, I end up with 725,000. Now to get x by itself, I'm going to divide both sides by 145. And x we get 5,000. Okay, how much did she invest in each account? So 5,000, what was x representing? The account was 6.5% interest. So I'm going to say account 1, which I labeled before, has $5,000 invested. And then how can I figure out how much is in account 2? Well, remember account 2, it had $4,500 more. So in account 2, I'm going to add 4,500 to 5,000. I'm going to get 9,500 is invested. And this makes sense, right? So these accounts should have quite a bit of money if she earned over $1,000 in interest, but not an insane amount. So you want to make sure that these accounts look logical, and you can always check your work. Take 6.5% of 5,000, take 8% of 9,500 to make sure that you end up, if you add those values, with $1,085. Take a deep breath, because we finished the first example. Let's look at the second example. Rebecca has $4.10 in nickels and quarters. The number of nickels is 4 more than the number of quarters. How many of each coin does she have? Now, the nice thing about coin questions is if you get stuck, you can always just, try them out, because you know that a nickel is worth 5 cents and a quarter is worth 25 cents. But this is algebra. We're going to do this the algebraic way. Here's what we know. And, we know that she has $4.10. And that $4.10 is a result of the value of the nickels plus the value of the quarters. Okay, now let's talk a little bit more. Let's look at the second sentence. The number of nickels, so we're going to call the number of nickels n, and the number of nickels is 4 more than the number of quarters. So we're going to say n is equal to 4 plus q, where q is the number of quarters. Okay, so we have a representation for the number of nickels in terms of quarters, but we need the values, right? We need to plug the values in here in order to make this work. Well, what's the value of a nickel? It's 5 cents. So we can say the value of the number of nickels, will be 0.05 times n. The value of however many quarters she has would be 0.25 times q. Okay, so now we can plug these in. We can say 410 is equal to the value of the nickels, 0.05 times n, plus the value of the quarters, 0.25 times q. We have the same issue that we had last time where we have 2 different variables and we need just one variable, but we have a representation right here. We know that we can rewrite n as 4 plus q. So let's do that. We have 410 equals 0.05 times 4 plus q plus 25 hundredths times q. Now, if you want to get rid of the decimals, you can. Find the least place. Here, well, technically we have tenths, hundredths, hundredths. So because we have a few with the hundredths, we're going to multiply by 100. That's moving the decimal point 2 places to the right. That would give me 410 is equal to 5 times 4 plus q plus 25q. Now we can distribute the 5. So we have 410 is equal to 4 times 5 is 20 plus 5q plus 25q. Combine our like terms and we'll subtract 20 from both sides. And that gives us 390 is equal to 30Q. Divide both sides by 30, and what does that give us? That gives us 13. So this says that the number of quarters she has is 13. Well, okay, so if she has 13 quarters, how many nickels does she have? She has 4 more than that, so that means she must have 17 nickels. And again, this one is a really nice one to check so you know you have the right answer. If she has 13 quarters, that's like $3.25. And if she has 17 nickels, that's 15 cents less than $1, so that'd be 85 cents. And if I add these together, I should end up with this value here, which I do end up with 410. So I feel pretty good that there are 13 quarters and there are 17 nickels. These have been some applications of money and interest problems. Thank you for bearing with me. You did great, and thank you for stopping by.